Consider two students carrying a 20-liter jerry can up a steep incline. The external workload is identical, yet the physiological response is entirely different. One completes the ascent at a steady, rhythmic pace. The other struggles after a few steps, pausing to gasp for air as their muscles fail to sustain the load. Looking at the internal biometrics, the steady student maintains a manageable heart rate of around 90 beats per minute. The struggling student's heart rate spikes to 160 beats per minute. This discrepancy is governed by physical fitness. It is the biological readiness of your cardiovascular, respiratory, and muscular systems to work together efficiently under load. When these biological systems are optimized, they protect you from extreme fatigue during daily labor, whether you are walking long distances to school or digging in the garden. Human fitness operates as a dual-category system. It relies on a structural, physiological foundation that is fine-tuned by a biomechanical execution layer. To move efficiently through daily life, we need to deconstruct how both of these systems function and how you can safely optimize them. Neglecting the body's maintenance eventually leads to structural exhaustion. To understand why, we must examine the specific mechanics that determine how the body produces and manages its effort. This diagram outlines the architecture of physical fitness. The structural foundation is built on the left side, health-related fitness. This category establishes your physiological baseline. It builds the overall stamina required for survival and actively protects the body against lifestyle diseases, such as high blood pressure. The core driver of this baseline is cardiorespiratory endurance. This measures the capacity of your heart and lungs to continuously supply oxygen to working muscles. If a student walks 5 kilometers to school without resting, they are relying on this endurance. Oxygen is drawn into the expanding lungs, pumped through the heart, and distributed across the vascular network to sustain the long effort. Taking your resting pulse and then taking it again after 2 minutes of jogging provides immediate proof of this mechanism. The cardiovascular system dynamically scales its oxygen delivery to match the physical demand. The next component is muscular strength. This is the absolute maximum force a specific muscle group can generate in a single, concentrated effort, like lifting a heavy bunch of matuke off the ground. Then comes flexibility. This is strictly defined as a joint's capacity to move through its complete, natural range of motion without triggering a pain response. Flexibility is a strict mechanical requirement for agricultural labor. Bending to weed a garden for hours requires specific degrees of movement at the hip joint and lumbar spine to avoid tearing delicate tissue. Maintaining this active lifestyle also regulates your body composition, achieving the optimal ratio of fat tissue to muscle mass for daily health. You can map out this entire physiological baseline using the acronym FACTS: flexibility, aerobic endurance, composition of the body, trunk endurance, and strength. If these internal components are not functioning efficiently, the human engine stalls long before the day's tasks are complete. Once the physiological baseline is set, we look at the right branch of the diagram, skill-related fitness. A persistent misconception is that these skills are reserved for professional athletes. In reality, skill-related fitness acts as the neurological software governing the mechanical efficiency of all human movement. The primary components necessary for overcoming environmental instability are balance and coordination. Consider a boda rider navigating a muddy village path. They stay upright by continuously shifting their body weight to counter the slip of the tires. This relies on complex physics. The rider's brain continuously calculates the body's center of mass against gravitational pull, applying a precise counterdirectional force to maintain equilibrium. Next are agility and speed, which determine your ability to rapidly change directional momentum and forward velocity. You see this when a netball player executes a sharp change of direction to bypass a defender, or when a pedestrian reacts to a hazard. Finally, there is power. This is the explosive output generated when you combine speed with raw muscular strength, required when jumping to spike a volleyball or leaping across a wide ditch. These performance skills cannot operate in a vacuum. To function correctly, they must be layered directly on top of a highly conditioned health-related foundation. Pushing any physical engine beyond its structural integrity guarantees failure. In the human body, that failure takes the form of an injury. Avoiding injury requires an awareness of your personal physical limitations. Pain is a biological alarm system signaling a mechanical threshold that must be respected. Observe structural failure by looking at poor lifting posture. Bending at the waist uses the fragile lower spine as a fulcrum, leveraging weight against small vertebrae. When the posture corrects by keeping the back straight and bending the knees, the mechanical load shifts entirely. This is trunk stability in action. Recruiting the massive muscles of the legs and maintaining a rigid core reduces spinal strain to near zero. Preparing the body for this exertion requires strict protocols. You must execute a physiological warm-up to increase blood flow to the muscles before starting heavy chores. Safety also extends to environmental awareness. This means wearing proper footwear and ensuring the work area is cleared of hazards like sharp stones or glass. Correct posture, warm-ups, and environmental safety are not optional suggestions. They are the fixed rules for keeping your body operational over a lifetime. The idea that physical fitness simply means having large muscles is a biological myth. An unbalanced physical system is an inefficient one. A person possessing massive muscular strength but poor cardiorespiratory endurance will still collapse from exhaustion while trying to carry water up a hill. This chart shows how true physical efficiency requires a precise alignment of both fitness categories for any given task. Slashing a compound demands muscular strength paired with coordination. Riding a bota requires flexibility paired with balance. By combining the health baseline with skill-based precision, you build a resilient physical engine capable of adapting to varying workloads. That engine requires daily maintenance. It demands safe practices, an understanding of your personal limitations, and a consistent effort to challenge both your heart and your muscles. Physical fitness functions as the primary foundation for daily activity. It sustains the effort required for education and labor, providing the stability needed to move efficiently through a healthy life.